Definition of a tangent introduction. Hello, everyone. Welcome to today's session on geometry. As we dive into our study of circles, you'll notice that we don't just look at the circle itself, but also at the various types of lines that interact with it. Some might pass through it, while others might just graze the edge. Today, we are going to focus on one of the most essential concepts in this topic, the tangent. Mastering the concept of the tangent is not just important for your current understanding, but it is also a fundamental building block for mastering all the properties of circles, and it serves as a key component of your Grade X NCERT curriculum. So let's get started. Definition of a tangent. What is a tangent? Now that we've introduced the concept of lines interacting with circles, let's dive into the formal definition. So, what exactly is a tangent? Mathematically speaking, a tangent to a circle is defined as a straight line that intersects the circle at exactly one point. Just one. It doesn't pass through the circle, and it doesn't miss it entirely. It meets the boundary at a single, precise location. To help you remember this and understand the concept more deeply, let's look at the linguistic origin of the word itself. The term tangent is actually derived from the Latin word tanger, which literally means to touch. If you think about it, this is a perfect description of how the line behaves. Unlike a line that might cut through the circle, a tangent does not penetrate the interior. It merely touches the outer boundary of the circle. Keep this idea of touching in mind, because in our next slide, we are going to compare this to a line that does indeed cut through the circle, known as a secant. Definition of a tangent, tangent versus secant. Now that we have established the basic definition of a tangent as a line that merely touches the circle, I want to make sure we don't confuse it with another type of line. To clearly define a tangent, it is very helpful to compare it with something called a secant. Now, keep in mind that both of these are straight lines that interact with a circle, but their behavior is fundamentally different. Let's look at the first case, the secant. Unlike the tangent we just discussed, a secant is a line that intersects a circle at two distinct points. You can visualize this as a line that cuts through the circle, passing from one side and exiting through the other, effectively passing through the interior of the circle. On the other hand, let's look at the tangent. As we learned in the previous slide, the tangent is much more delicate. It intersects the circle at only one single point. Unlike the secant, it stays on the exterior of the circle, meeting the boundary only at that one specific point of contact. In the next slide, we will summarize these differences in a table to help you keep them straight for your exams. Definition of a tangent summary table for comparison. Now that we have looked at the individual definitions of the secant and the tangent, let's bring them together in this summary table to see the clear distinctions between them. This is a great way to review before we move on to a real-world application. First, let's look at the number of intersection points row. This is the most critical mathematical difference. As we discussed in the previous slides, a secant line intersects the circle at two distinct points, whereas a tangent line intersects the circle at exactly one point. Next, let's examine their relationship with the circle. If you think about the word tanger that we just learned, it means to touch. So, while the secant cuts through the circle, the tangent merely touches the outer boundary. Finally, let's look at their position relative to the circle. A secant line must pass through the interior of the circle to reach those 2 points. In contrast, the tangent remains entirely in the exterior of the circle, with the sole exception of that one single point where it meets the boundary. Keep this comparison in mind, because in the next slide, we are going to see how this exact same principle applies to something you see every day: a bicycle wheel on a flat road. Definition of a tangent, real-world example, the bicycle wheel. Now that we have established the formal definitions and compared the tangent with the secant, let's move away from abstract diagrams and look at something you see every single day. This will help you truly visualize what we mean when we say a line touches a circle. Think about a bicycle wheel resting on a perfectly flat, straight road. Let's break this down step by step to see the geometry in action. First, look at the tire itself. If we were to look at the loop from the side, the circular cross-section of the tire represents our circle in a two-dimensional plane. Next, consider the road. The surface of that flat road represents our straight line. Now, observe the interaction between the two. Notice that the tire doesn't sink into the pavement, nor does the road cut through the middle of the wheel. It doesn't pass through the interior of the circle like the secant we discussed in the previous slide. Instead, look closely at the very bottom of the tire. There is only one specific, tiny point where the rubber of the tire meets the surface of the road. This is our single point of contact. So, to conclude our observation, in this real-world scenario, the flat surface of the road acts exactly as a tangent to the circle formed by the bicycle wheel. This brings us to our final summary and some important tips to keep in mind as we move forward. Definition of a tangent. Key takeaways. First and foremost, remember the core definition. A tangent is a straight line that touches a circle at exactly one single point. It doesn't cut through the circle, it just grazes the edge. To help you remember this, keep that Latin root in mind which we discussed earlier, tangere, which literally means to touch. If you remember that word, you'll never forget the behavior of the line. Now, I want you to be very careful not to confuse this with what we studied in the previous slides, the secant. As we compared them, remember that a secant intersects the circle at two distinct points, whereas a tangent, as we've established, intersects at only one. Finally, there is a specific term you must use in your exams. The exact spot where the tangent meets the circle is formally known as the point of contact. All right, class, we have covered a lot of ground today, so let's take a moment to consolidate everything we've learned. This summary slide is crucial for your revision. Keep these points clear in your mind, because in our next slide, we are going to look at some common pitfalls where students often lose marks by misidentifying these lines. Definition of a tangent. Common mistakes to avoid. First, let's talk about the mistake of confusing a tangent with a secant. It is very common to see a line that passes extremely close to the center of the circle and mistakenly label it a tangent. However, you must apply the rule we discussed in slide 3. If that line enters the interior of the circle and exits through another point, it has 2 points of intersection. Therefore, it is strictly a secant, not a tangent. Secondly, please avoid the assumption that a tangent crosses the circle. This is a crucial distinction. A tangent, as we learned from the Latin root tangere, merely touches the boundary. Remember, a line is infinite in both directions. If a line enters the circle's area, it must eventually exit through another point. If it enters and exits, it is no longer just touching, it is cutting through, which makes it a secant. Finally, be careful not to misidentify the point of contact. Always verify the number of shared points. To be a true tangent, the tangent and the circle must share exactly one common point. If you count 2 points of intersection, you are no longer looking at a tangent. Now, before we conclude our lesson, I want to pause and address some common pitfalls. As we have seen throughout this presentation, from our initial definition to our comparison with the secant, precision is everything in geometry. Keep these distinctions in mind, and you will master the properties of circles with much greater ease.